Hello students, I am your science teacher Preeti ma'am and I am going to teach you matter in our surroundings. The topics that I am going to cover in this chapter are the common unit of temperature and the SI unit of temperature, changes in the states of matter, what is the effect of change of matter if we change it from solid to liquid, liquid to gases, gases to liquid and liquid to solid. I will also teach you latent heat of fusion and latent heat of vaporization. And the last topic of this lecture will be sublimation. Students, we use the Celsius scale to measure the temperature for measuring the temperatures in our daily life. The common unit of measuring temperatures like the melting points and the boiling points is the degree Celsius, which is written in short form as degree and C, capital C. The laboratory thermometers which we use for performing science experiments are all calibrated in degree Celsius. Even the clinical thermometer that we use it for measuring human body temperature is calibrated as Celsius scale of temperature. The melting point of ice on the Celsius scale of the temperature is 0 degrees Celsius, and the boiling point of water on the Celsius scale of temperature is 100 degrees Celsius. There is another scale of temperature also which is called as the Kelvin scale of temperature, which is used by the many scientists mainly for the research work. The SI unit of measuring temperature is Kelvin, which is written as capital K. The word degree or its sign degree Celsius is not written with the Kelvin. So you are going to remember this. An advantage of the Kelvin scale of temperature is that all the temperatures on this scale, they are all positive. The melting point of ice on the Kelvin scale is 273 Kelvin. This is a famous scientist who invented the Celsius scale of temperature. He is Andreas Celsius, and this great scientist is Lord William Thomson Kelvin. He is the person who invented Kelvin scale of temperature. The melting point of ice on the Kelvin scale is 273 Kelvin, and the boiling point of water on Kelvin scale is 373 Kelvin. Students, we must learn that the melting point of ice on the Celsius scale is 0 degrees Celsius, and on the Kelvin scale it is 273 Kelvin. What does this mean? This means that the temperature of 0 degrees Celsius on Celsius scale is equal to 273 on the Kelvin scale. So 0 degrees Celsius is equal to 273 Kelvin. Then what is the relation between Kelvin scale and the Celsius scale of temperature? How are we going to find out? It's very simple. What are we going to do? Temperature on the Kelvin scale will be equal to temperature on the Celsius scale, and then we are going to add 273 to it. And this relation can be used up to convert the Celsius temperature into Kelvin temperature, or Kelvin temperature into the Celsius temperature. We should also remember that the relation the above relation I told you, relation between the Kelvin and the Celsius, it will be used to solve the numerical problems also. Let us take one example. We are going to convert temperature of 25 degrees Celsius into Kelvin scale. So what are we going to do? If you want to convert temperature on Kelvin scale, then in 25 degrees Celsius, we are going to add 273. And if we add 273, what would it be? It would be 298. So this will be 298 Kelvin. So same way, I'll teach you to solve one more sum. If a question is something like this, that you are going to convert 300 Kelvin to Celsius scale. The question is 300 Kelvin. You are going to convert into Celsius. So what are you going to do? Temperature on Kelvin scale will be 300, will be equal to temperature in the Celsius scale plus 273. So what are we going to do? We are going to minus from 300 273. And if we minus, what will be our answer? 27 degrees Celsius. So this is how we are going to convert it. So it is clear from the discussion we made now that to convert the temperature on Celsius scale to Kelvin scale, we are going to add 273 to the Celsius temperature, and to convert the temperature on Kelvin scale to Celsius scale, we are going to subtract 273 from the Kelvin temperature. Is it clear, students, now how to convert it? Now let's look at the changes of states of the matter. You know, students, matter exists in three physical states: the solid state, the liquid state, and the gaseous state or vapor state we can call. Let me give you one example. Water exists as a solid and in the form of ice, as a liquid is in the form of water and gas is in the form of steam or water vapor. Water comes as ice out of the freezer of the refrigerator, as water out of the tap, and as steam, means I am talking about water vapor, out of the kettle of boiling water. You can see over here, this is ice which is kept, this is water, and this is steam, the water vapor which is coming out. So we can change the physical state of matter in two ways. So which are the two ways? By changing the temperature and by changing the pressure. So according to this, we can say that we can change the state of matter by changing the temperature. We mean that the state of matter can be changed by heating it or by cooling it. And when we say that we can change the state of matter by changing the pressure, we mean that the state of matter can be changed by increasing the pressure on it, means by compressing it or by decreasing the pressure on it. So we can say that the two factors which decide whether the given substance would be in the solid, liquid or gaseous state are the temperature and the pressure. Now students, let us discuss the effect of change of temperature and the effect of change of pressure on the physical state of matter one by one. By increasing the temperature, means by heating, a solid can be converted into liquid, and a liquid can be converted into gaseous form or the vapor form. And by decreasing the temperature, means by cooling, a gas can be converted into liquid state and a liquid can be converted into solid state. So we are going to discuss all these points in detail now. Solid to liquid change is called as the melting. If we heat ice, it changes into water. If we heat ice, it changes into water. And in this case, solid ice changes into liquid water. So a change of state has taken place. Yes? The process in which the solid substance changes into liquid on heating, it is called as melting. Solid substance changes into liquid state, it is called as melting or fusion. So when ice changes into water on heating, it is called as melting of ice or fusion of ice. A change of state takes place during melting. The melting of the solid substance takes place at a fixed temperature. The temperature at which a solid substance melts and changes into liquid at atmospheric pressure, it is called as the melting point of substance. The melting point of solid is the measure of the force of attraction between the particles of matter. Because the ice melts at a temperature of 0 degrees Celsius to form into a liquid state. So the melting point of ice is 0 degrees Celsius. Different solids, they have different melting points. Like the melting point of ice is 0 degrees Celsius, wax is 63 degrees Celsius, maybe iron may be 1535 degrees Celsius. So the melting point of a solid is the measure of the force of attraction between the particles of matter. Means higher the melting point of a solid substance, greater will be the force of attraction between the particles. When a solid is heated sufficiently, it changes its physical state and it becomes liquid. When a solid substance is heated, the heat energy makes its particles vibrate very fast, very vigorously. At the melting point, the particles of the solid have sufficient kinetic energy to overcome the forces, the strong forces of attraction which are holding them in fixed places, in fixed position, and break to form small groups of particles. And the solid melts to form the liquid. Now let's see what happens in liquid to gas change. You know students, water normally exists in a liquid state. If we go on heating water, it ultimately starts boiling and changes rapidly into a gas, which is called as the steam. In this case, the liquid water changes into gas. So a change in state has taken place over here. So the process in which the liquid substance changes into a gas rapidly on heating, it is called as boiling. So when water changes into steam rapidly on heating, it is called as boiling of water. A change of state takes place during boiling. The boiling of the liquid takes place at the fixed temperature. The temperature at which the liquid boils and changes rapidly into a gas at atmospheric pressure, it is called as the boiling point of the liquid. Let me give you an example. When water is heated to a temperature of 100 degrees Celsius, it boils rapidly to form gas, which is called as steam. So the boiling point of water is 100 degrees Celsius. At boiling point, water changes its state from liquid to gaseous. Different liquids, they have different boiling points. Like the boiling point of alcohol is 78 degrees Celsius, Water, as I told you, is 100 degrees Celsius. The boiling point of mercury is nearly 357 degrees Celsius. Means different substances, they have different boiling points. The boiling point of a liquid is a measure of the forces of attraction between its particles. Higher the boiling point of a liquid, greater will be the forces of attraction between the particles. Means to say that the boiling point of mercury is very high. It is 357 degrees Celsius. And from this we come to know that the force of attraction between the particles of mercury is very, very, very strong. When a liquid is heated, it changes its physical state and becomes gas. Now let us discuss about the gas to liquid change, which is called as the condensation. Students, if we cool steam, water vapor, by lowering its temperature, it is converted into liquid water, and in this case a gas or steam changes into liquid. So a change of state has taken place. The process of changing gas to a liquid by cooling, it is called as condensation. I repeat, the process of changing a gas or vapor to a liquid form by cooling, it is called as condensation. So when steam means water vapor changes into water on cooling, it is called as condensation of steam or condensation of water vapor. A change of state means from gas to liquid takes place during condensation. When a gas is cooled enough by lowering its temperature, then its particles lose so much kinetic energy that they slow down, move closer together until they start being attracted to each other to form liquid. And condensation is the reverse of boiling. This experiment setup shows the process of condensation. When we hold the frying pan containing some ice just above the spout of kettle of boiling water, then the hot steam coming out of the spout comes in contact with the bottom, ice cold bottom of frying pan. It gets cooled and condenses to form drops of water, drops of liquid water. Now let's discuss about liquid to solid change, means freezing. When water is cooled by lowering the temperature by keeping in the freezer compartment of a refrigerator, it changes into solid ice. The process of changing a liquid into a solid by cooling, it is called as freezing. Let me give you one example. When water is cooled, it gets converted into the solid called the ice, and this is called as freezing of water. Freezing means what? Freezing means a solidification. When water freezes to form ice, then there is a change from liquid state to a solid state. Freezing is the reverse of the melting process. The state of matter can be changed by changing the temperature by heating or cooling. When a liquid is heated further, it boils to form gases. When liquid is heated, it boils to form gases. These changes can be easily reversed. For example, when gas is cooled, it forms liquid. And again, when liquid is cooled, it forms solid. So this is all the process. Now let us study a new topic, latent heat. Normally when heat is given to a substance, then its temperature rises. This, however, is not so when a change of state of a substance takes place. Because when heat is given to change the physical state of substance, means from solid to liquid or liquid to gas, there is no rise in the temperature of a substance at all. The heat energy which has to be supplied to change the state of substance, it is called as its latent heat. Latent heat does not rise or increase the temperature, but latent heat has always to be supplied to change the state of a substance. Latent means hidden. It is called latent heat because it becomes hidden in substances undergoing the change of state and does not show its presence by rising the temperature. So latent heat, which is given to change the substance of state of a substance, cannot be detected by the thermometer. Why latent heat does not cause a rise in the temperature of a substance? Do you know that? Every substance, whether it is a solid or a liquid, has some force of attraction between its particles which hold them together. If a substance has to change its state, then it is necessary to overcome these forces of attraction between its particles. So latent heat which is supplied is used up in overcoming the forces of attraction between the particles of a substance during the change of the state. The latent heat does not increase the kinetic energy of a particle of the substance. And since there is no increase in the kinetic energy of the particles, the temperature of a substance does not rise during the change of the state. Latent heat is of two types. One is the latent heat of fusion and another is the latent heat of vaporization. The heat required to convert solid into liquid state, it is called as a latent heat of fusion, and the heat required to convert a liquid into a vapor form, it is called as the latent heat of vaporization. Now let us discuss both of these types in detail. First, let us discuss about the latent heat of fusion, means how it changes from a solid to liquid changes. What happens in that? The latent heat of fusion will conduct one experiment. Here we have taken some crushed ice in the beaker. We have taken some crushed ice in the beaker and we have suspended a thermometer in it. If we note the temperature, it is found that it is 0 degrees Celsius. We now heat the ice gently by using very small flame. And we will keep on recording the temperature of melting of the ice on the thermometer every minute. As more heat is given, more ice melts to form water, but the thermometer reading remains as it is, 0 degrees Celsius. There is no change in the temperature. As long as there remains even a little ice, a small piece of ice in the beaker, the temperature does not rise at all. It remains constant at 0 degrees Celsius. There is no rise in the temperature during the melting of the ice. It is only when all the ice which is there, which has melted, then the temperature of water, it will start rising if we heat it further. The heat which is going into the ice but not increasing the temperature is the energy required to change the state of ice from solid to liquid, and this is known as the latent heat of fusion. Latent heat of fusion, there is no rise in the temperature during the melting of the ice. The latent heat of fusion means of melting of a solid is the quantity of heat in joules required to convert 1 kilogram of solid to liquid without any change in the temperature. So the latent heat of fusion of ice is 3.34 multiplied 10 raised to 5 joules per kg. Where does the heat energy go then? We have been supplying energy, but there is no increase in the temperature. Then where did this heat energy go? Actually, this heat energy is used up in changing the state of solid substance by overcoming the force of attraction which is present between the particles. Why the temperature of melting ice does not rise even though the heat is being supplied continuously? I will explain you. Ice is a solid substance. So the particles of the ice attract one another with strong forces, with great forces, and these forces of attraction hold the particles closely packed in the solid substance between the ice particles so that they become somewhat loose and form the liquid form. The heat which we supply to ice during melting is all used up in overcoming the forces of attraction between the ice particles, and they now become loose and they form into liquid. And this heat does not increase the kinetic energy of the particles, and so there is no rise in the temperature taking place during the melting of the ice. But when all the ice has melted and formed into water, so on further heating, if we heat further, now we can see that there is change in the temperature because there is increasing the kinetic energy of the water particles, due to which the temperature of water starts rising up. Now let's discuss about the latent heat of vaporization, means change from liquid to gaseous change. Same way we are going to conduct one activity. Now instead of ice, we are going to take water in the beaker and suspend thermometer as we had done there. And if we heat this water by using the burner and note the temperature every minute as the heat is given, the temperature of water rises gradually until 100 degrees Celsius is reached. And at the temperature of 100 degrees Celsius, the water starts boiling and starts changing into steam. At 100 degrees. At the temperature of 100 degrees Celsius, water boils and starts changing into steam. As more heat is given to water, more steam is formed, but in the thermometer reading, it remains the same as 100 degrees Celsius, showing that there is no rise in the temperature during the boiling of water. Once the water has begun to boil, the temperature remains constant at 100 degrees Celsius until all the water has changed into steam. The heat which is going into boiling water but not increasing the temperature is the energy required to change the state of water from liquid to gas. And this is what is known as the latent heat of vaporization. The latent heat of vaporization of a liquid is the quantity of heat in joules required to convert 1 kilogram of a liquid at its boiling point to vapor or gas without any change in the temperature. The heat supplied to a boiling liquid is used up in changing the state of a liquid substance by overcoming the forces of attraction between its particles. Then students, why the temperature of boiling water did not change, did not rise, even though the heat is being supplied continuously? You know students, water is in liquid state. The particles of water attract one another with some force. Not as strong as the solid, but there is some force of attraction, and these forces of attraction hold the water molecules together, water particles together in the liquid state. The heat which is supplied to water during boiling is used up to overcome or to break the forces of attraction between the water particles, and so they become totally free and change into gas. This latent heat does not increase the kinetic energy of water molecules, and so no rise of temperature takes place during the boiling of the water. The latent heat of vaporization of water is 22.5 multiplied 10 raised to 5 joules per kg. Sublimation. We have discussed now that solid changes on heating to liquid, liquid changes on heating to gases. Most of the substances when heated, first they always change into liquid and then they change into vapors or gas. This vapor on cooling, it forms into liquid and then into solid. But students, there are few substances, few solid substances which change directly into vapors on heating, and the vapors give back solid substance on cooling without passing through the liquid state. There is no liquid state in this. So, the changing of liquid directly into vapors on heating and of vapors into solids on cooling, it is called as sublimation. So we will see that solid on heating changes into vapor, and vapor on cooling it changes into solids. So what did we observe? We noted that the changing of solid directly into vapors is called as sublimation, and the changing of vapors directly into solid is also called as sublimation. The solid substance which undergoes sublimation, it is called as sublime, and the solid obtained by cooling the vapors of a solid, it is called as sublimate. I repeat, the solid substance which undergoes sublimation, it is called as sublime, and the solid obtained by cooling the vapors of solid, it is called as sublimate. Some examples: ammonium chloride, it undergoes sublimation. When ammonium chloride is heated, it directly changes into ammonium chloride vapors without passing into liquid state. And when hot ammonium chloride vapor is cooled, it directly changes into solid ammonium chloride. without passing through the liquid state. Sublimation occurs only in a few substances. So which are the substances that undergo this sublimation? Because it is very rare process. The common substances which undergo the sublimation are ammonium chloride, iodine, camphor and naphthalene. Solid carbon dioxide, which is also called as dry ice, sublimes to form carbon dioxide gas. And in many households, some naphthalene balls, they are kept in stored woolen or silk clothes to protect them from the attack of the moths and other insects. We will notice that these naphthalene balls disappear with time without leaving behind any residue. The naphthalene ball disappear with time without leaving any residue. This is because naphthalene balls, they undergo sublimation. The naphthalene balls kept on forming naphthalene vapors slowly, which disappear into the air. Let us see effect of change of pressure now. But before that, here you can see that solid iodine is sublimes on heating. Iodine is sublimes on heating, and this means that solid iodine gets converted directly into vapors on heating. And you will also see that solid ice, solid carbon dioxide sublimes on heating and can be used to create the special effects on stage as it is shown over here. The naphthalene balls. Naphthalene is an organic compound which undergo sublimation. This is a triangular interconversation of the three states of matter which is shown over here in the states of matter triangle. It shows that solid on melting forms liquid, liquids on boiling they form gases, and gases on sublimation they form solids. So this is triangle which you will understand. Solids on sublimation they form gases, gases on condensation they form liquid, and liquid on freezing they form the solids. And thus we end up over here. If you like this, then like it, share it and subscribe it. But before that, answer to these questions. Write in your books and keep it ready. So bye bye students. Bye. See you all.